Number 1, there are 55 students in Spanish Club. A sample of the Spanish Club students was selected at random and asked whether they intend to enroll in a new study program. Of those surveyed, 20% responded that they intend to enroll in the study program. Based on this survey, which of the following is the best estimate of the total number of Spanish Club students who intend to enroll in the study program? Now, I'm emphasizing that each time because, here we go, intend to enroll, intend to enroll, intend to enroll. Anytime you have a fairly long word problem like this, it's very good to make sure that we're being given the same information each time, or check and see if we're being given different information each time. For example, I wouldn't put it past them to have the first two instances to say intend to enroll, and then the question be, well, what's the best estimate for those who don't intend to enroll? Be very, very careful on that. It's easy to get tripped up. But this one is straightforward. Each time, intend to enroll. So we are starting with 55 students, and we are told that 20% say they intend to enroll. And we want to know what's the best estimate of how many students that is. So a couple of ways you can look at this. We are allowed to use calculators on this. So we want to know what is 20% of 55. So if you're using a calculator, you would say 55 times 20%, which is 0.2. And that's going to give you 11. Another way you can look at this, if you don't want to use a calculator, you could say 20% is the same as 1/5. What is 1/5 of 55, or 55 divided by 5? Once again, we would get 11. So A, 11 is our answer. Number 2, Jay walks at a speed of 3 miles per hour and runs at a speed of 5 miles per hour. He walks for W hours and he runs for R hours for a combined total of 14 miles. Which equation represents this situation? Now, some of you out there may be able to look at these 4 answers and sort of logic process of elimination, like must add up to this doesn't make sense, why would it be this or that? If you can do that, that's totally fine. I'm going to go through the strictly math-based perspective to this, but if you can do it with the logic, I'm not going to stop you. Frankly, it's probably a little faster, and time is of the essence for these. But here is the very strict sort of mathematical way to do this. Distance is equal to rate times time. So we know that Jay was walking. We know his rate. We're told this twice. Come on. There we go. Persnickety little highlighter. All right, we know his rate when he is walking is 3 miles an hour, and we know his rate when he's running is 5 miles per hour. Okay, so we have 2 rates. Do we have times? Well, we kind of do. We have W hours and R hours. So we have variables, but those are the times. And do we have a distance? We have the combined distance. The combined distance is 14. So let's start putting this together. So I could say this. I could say the distance of walking. So the distance, and I'm just going to put walking here. This doesn't mean multiply. This is just, I'm just saying, I'm setting up my equation. The distance when walking plus the distance, and this is when he's running, would equal the total distance of 14 miles. Okay? With me so far, 2 distances. All right, now the distance when he's walking is a rate times a time. And the distance when he's running is a rate times a time. And together, those are going to equal 14. All right, so first, when he's walking, what is the rate when he's walking? We are told it is 3 miles an hour. What is the time when he's walking? We're not given a number, we're given a variable. We're told it is W hours. So there's my time, 3 times W, rate times time. Now the distance when he's running is the rate times the time over there. What's the rate when he's running? It is 5 miles per hour. And what is the time when he's running? We don't know exactly. We're told it's a variable R, or it's not, I should say it's a constant R. Excuse me, not a variable, a constant R. So 3w plus 5r. That's it. We've written down the information they've given us. There's the distance, rate times time while walking. There's the distance, rate times time when running, and their combined distances, we add those together, is 14. Now let's look over here at our choices, and do any of these match? 3w plus 5r equals 14. Sure enough, right there, A, that is our answer. Number 3. The scatter plot shows the relationship between two variables x and y. A line of best fit is also shown. Which of the following equations best represents the line of best fit shown? This is absolutely a case where look at these answers first. Don't go up here and start trying to figure out the slope and the y-intercept and stuff like that. Start down here. So we're going to be using our standard y equals mx plus b. And we want to figure out what the m and the b are most likely for this, or which of these equations, I should say, has the m and the b that are most likely for this line. So our m is our slope, our rise over run, and our b is our y-intercept. So first, I've got two different y-intercepts here. I have two lines that have 1.7, positive 1.7 as the y-intercept, and I have two that have a negative 1.7 as the y-intercept. All right, so first things first, I'm going to look up here. Is that a positive or is that negative? That is positive. Here is 0. I'm going up. These are all positive numbers. So right off the bat, B and D with their negative y-intercepts are out. Okay, so now these two remaining, A and C, have the same y-intercept, but they have different slopes. One has a positive slope, 2.8. One has a negative slope, negative 2.8. If you're starting at the left and you're going towards the right, if the line is going upward at all, even the slightest bit, that is a positive slope. We are not talking about, to be clear, we're not talking about horizontal or vertical lines, just lines that are either rising or descending. If when you're going left to right, like how you read in English, if you're going upward, that is a positive slope. If you're going downward, that's a negative slope. That's just a general rule of thumb. If you forgot that fact when you're on the test, another thing you can do is rise over run. You take 2 points on the line, and like just getting close is going to be good enough. So like maybe that point, and where's another one where it comes close to an intersection? There's a point right there. You could take those points and see how far up does it go and how far to the right does it go. And this is going to give you a positive number because you're going up towards the positive, so it's a positive number on top. The rise or change in y goes on top. And then it's going towards the right, towards the positive x, so it's going to be a positive number on the bottom. Positive divided by a positive is a positive. So that's another way to confirm. If you forget the sort of rule about like ascending as you go left to right is positive, descending left to right is negative, you can just go ahead and use those numbers, and even use the actual real numbers from the graph to confirm that. But that is a positive sloped line. So A, with that positive 2.8, is my answer. That negative slope is not. All right, number 4, another graph. The graph of y equals f of x is shown in the xy plane. What is the value of f of 0? When we have a function, like in this case, we have f of x, y equals f of x. Any number that you put in for x, the output after it goes through this function is going to give you your y coordinate when you graph it. That's what this means. You pick an x, you plug it into this function, which they're not telling us what the function is. They're not giving us the exact function here. They're just telling us this is a function, f of x. So what is f of 0? What happens when you plug 0 in for x? So that's it. That's all they're asking is what happens when x is 0. So we're going to look at this graph. We're going to zoom in. All right, so here is where x is 0 everywhere on this line. So where does this function touch? Where x is 0? Right there. When x is 0, y is 3. That's all they're asking. That's all that lengthy verbiage. The graph of y is the value of f of 0. It just means when x is 0, what is the y coordinate on this function? And it's 3. And that is D. That is our answer. 5. Which expression is equivalent to m to the fourth q to the fourth z to the negative 1 times m q to the fifth z cubed, where m, q, and z are positive? This is testing your exponent rules, like you know when you multiply variables with exponents. So I'm just going to write them down kind of in one long chain because these aren't connected to each other. They're not attached to each other. You can write it just like this: m to the fourth times q to the fourth times z to the negative 1 times m times q to the fifth times z cubed. And then when you're multiplying things, because of the commutative property of multiplication, we can change the order. So I'm going to put all the matching pairs together. So I have m to the fourth times m. I'm going to cross them out as I go. And then I have q to the fourth times q to the fifth. Get rid of those. And last but not least, I have z to the negative 1 times z cubed. All right, I got everybody. Now the exponent rule, when you have the same base, this variable down here is the base, and we have our powers up there. This is the one kind of thing you definitely need to know for this. If there isn't an exponent there, that is an invisible 1. M is the same as m to the power of 1. That's critical. So what you're going to do, if you have the same base, you add the exponents to multiply them together. Here is the reason why. If I have m to the fourth times m to the fourth is m times m times m times m. We have that one extra m. Boom. How many m's do I have? 5. M is being multiplied by itself 5 times. Since I told you this is an invisible 1, what is 4 plus 1? 5. That's the rule. And it works even with when you have negative numbers like over here. It always works. And I'm going to have videos linked down below if you'd like a more in-depth explanation for why it works, even with negative 1s, negative 2s, negative exponents. But for the purpose of this particular problem, they are just testing that you add the exponents. So let's go ahead and do that. M to the fourth times m, 4 plus 1 is 5. So that's m to the fifth. Q to the fourth times q to the fifth, 4 plus 5 is 9. So that's q to the ninth. Z to the negative 1 times z cubed, negative 1 plus 3 is 2, z squared. So m to the fifth, q to the ninth, z squared. And there we go. It is B. That is our answer. Zoom in on this one. Number 6, 73, 74, 75, 77, 79, 82, 84, 85, 91. What is the median of the data shown? Median means the number that is physically in the middle of the data set. Not if you had them on a number line, like which one would be closest to the middle. No. It literally means if I had, let's say if I had 1, 2, 3, 4, 5, 6 numbers, 5 number ones and then 100. It'd be like, I should add another 1 right there. Say, what is the median? It's the number that is physically in the middle. It's in the middle of the list. It's 1. So it's not the number that's in the middle between 1 and 100. That'd be 50. Nope, it's that little 1 right in the middle. It's in the middle of the list. Now, in this case, I had 1, 2, 3, 4, 5, 6, 7 numbers. So I have 3 numbers on the left, 3 numbers on the right. There's the monkey in the middle. Easy to find. If you have only an even number, like right here, now I have 6 numbers in the list. What you do, since you don't have a single number that's in the middle, is you find the 2 numbers that are closest to, because this is the middle spot and there's nothing there. So you find the number to the left and the right and you average them together. So in this case, 1 plus 1 is 2, divided by 2, we're back to 1. Yeah, the average, the median on this one would also be 1. So it's just the number that's physically in the middle of the list, or if there's not a single number, you take the number left and right of what would be the middle and you average them. So let's see how many numbers are in this list. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is an odd number. So there will be a number in the middle of the list. The way you find that number is you're going to divide this by 2. 9 divided by 2 is 4.5 or 4.5. You round it up. So the fifth number is the one you want. So 1, 2, 3, 4, 5. There's the number right smack dab in the middle. 79 is the median of the data set. Okay, number 7, x plus 40 equals 95. What value of x is the solution to the given equation? When you have an equation in algebra, balance is key. It's like a teeter-totter. The left and right sides, they are equal to each other. They have to stay balanced. So anything I do to the left, I also have to do to the right. So to get x by itself, I want to undo everything that's been done. 40 has been added to it. So to undo that, I do the opposite. I subtract 40. But again, because we have that equal sign and things have to stay balanced, I have to do the same thing on the right as well. So I've subtracted 40 from both sides. On the left, those 40s, add 40 minus 40, that cancels out. And I am just left with x. And on the right, 95 minus 40 is 55. And that is my answer. X is 55. Number 8, 5x equals 15 and negative 4x plus y equals negative 2. The solution to the given system of equations is x, y. What is the value of x plus y? Now, a lot of times with these 6 systems of equations, they will give us 2 equations that have an x and a y in both of them, by which I mean this equation would have an x and a y, and this equation would have an x and a y. Now, when you have those, you need to solve using substitution or elimination. And I'm putting links to all these concepts in the description below if you need information on that. But this one, they're being a little nice. They don't have a y in that first one. They only have an x. So that should be much easier for us to solve. That first equation we can solve for x. 5 times x equals 15. We want to undo what's been done to x. X has been multiplied by 5. The opposite of multiplication is division. So we're going to divide both sides by 5. 5 times x divided by 5 cancels out, just left with x. And 15 divided by 5 is 3. Right, so I know x equals 3. I'm going to write that over here. Erase this. Okay, so now my second equation that I'm given is negative 4x plus y equals negative 2. Now I know x is 3, so I'm going to plug it in there. Negative 4 times 3 plus y equals negative 2. Negative 4 times 3 is negative 12. Oh, and I wrote negative 12 on the right. I'm sorry about that. Getting ahead of myself. It's still just a negative 2 on the right. And there, that negative 12 is being added to y. And because this is a negative 12 plus y, you actually could rewrite this as y minus 12. You can reorder it like that. Perhaps make it a little easier to see that the way to undo this is to add 12. So you have that negative 12 or minus 12. You want to add 12, put a positive 12 there to undo it. We want to do that to both sides. So on the left, y minus 12 plus 12, and we just have y. And on the right, negative 2 plus a positive 12 is a positive 10. So now I know y equals 10. But is that what they asked? Nope. The question is, what is the value of x plus y? So what is 3 plus 10? It is 13, and that is C. Number 9, g of m equals negative 0.05 m plus 12.1. The given function g models the number of gallons of gasoline that remains from a full gas tank in a car after driving m miles. According to the model, about how many gallons of gasoline are used to drive each mile? Okay, so for this, I find the easiest way is to really see what's going on with these equations that they create is to pick a number or two and plug them in and see what happens. Let's say I plug in 0. 0 for m miles, 0 for miles. What does that mean? Okay, let's read this again what it says. It's the number of gallons that remain after driving m miles. So if I put in 0, that means I haven't driven any miles. So it should represent what a full gallon of gas, or excuse me, a full tank of gas would be, right? I haven't driven anywhere. So I'm going to plug in a 0 for m. I have driven 0 miles. So that gives me negative 0.05 times 0 plus 12.1. Anything times 0 is just 0, so that's gone. 0 plus 12.1 is 12.1. So when I have gone 0 miles, I have 12.1 gallons of gas. All right. Well, what would happen up here if I had driven 1 mile? Just 1 mile for M. Then it would be negative 0.05 times 1, which is negative 0.05, plus 12.1. So I'm going to be essentially subtracting 0.05 from my initial 12.1 gallons. So I drove 1 mile and my number of gallons went down by 0.05 for that 1 mile. So what's our question? According to the model, about how many gallons of gas are used to drive each mile. That's it, 0.05. When I put in 1 mile into this equation, my number of gallons of gas went down by 0.05. So it would be 12.05 gallons after that 1 mile. And so that's it. 0.05 is the number of is the amount of gallons of gasoline they're used to drive each mile, and that is A, 0.05. Number 10, 1 over 7b equals 11x over y. The given equation relates the positive numbers b, x, and y, which equation correctly expresses x in terms of b and y. Anytime you see put this x in terms of, what they're wanting you to do, whatever they're saying, put blah, blah, blah in terms of, etc. That blah, blah, blah in terms of, that needs to be all by itself on one side, and everything else in that equation needs to be over on the other side. So when it says expresses x in terms of b and y, x needs to be by itself on the left, and everything else that's in this equation needs to have moved to the other side. And it just needs to be a single x equals something. So let's take this initial equation. We have 1 over 7b equals 11x over y. There's a couple of ways you can do this. Neither way is wrong. They both give you the right answer. One way you can do it is to start by getting rid of this y, and it moves the y over here. You're still going to have a fraction. Then you get rid of the 7b, moves it. I think, and there's nothing wrong with that method at all. In fact, I think when I did this the first time, I always take these tests myself, just as like a quick little practice run before I start explaining it to other people. I think that's how I did it when I first looked at it. But looking at it now, I think the simpler way to do this is to cross multiply. It will get rid of your fractions immediately, and then you can simplify it pretty quickly. So let's cross multiply. 1 times y is y. On this side, 7b times 11x. We can do 7 times 11. That is 77. And then just the b and the x stay by themselves. Now remember, we want x all by itself. So what is being done to x? X is being multiplied by 77b. So we need to divide by 77b. And we need to do that to both sides because it is an equation. So it's going to cancel those out on the right. And I am left with x equals y over 77b. Now let's look over here and see. Yep, sure enough, there is a match for that. It is C. X equals y over 77b. Number 11, y equals 76 and y equals x squared minus 5. The graphs of the given equations in the xy plane intersect at the point x, y. What is a possible value of x? There's 2 ways to do this. One is using a graphing calculator. The other is mathematically. Your mileage may vary, whichever is easier for you. Personally, I think mathematically is a little quicker, but there's nothing wrong with doing it in the graphing calculator. You have access to that on this test, so absolutely use that if you want to. If you put it in the graphing calculator, this is what you're going to get. And I'm not drawing this to scale. This is really zoomed out. You're going to get a horizontal line. That's going to be your y equals 76. And you're going to get a parabola that's going to start down at -5. Again, this is not drawn to scale. And then it's going to go up on either side. And what you're going to want to do is to zoom in and find these 2 points of intersection. Make sure it's very precise that you are getting the point where they cross. When you find that point, y is going to be equal to 76 at both locations. It's kind of the telltale that you know you've hit the right spot. So whichever of those 2 points, you're going to get those 2 coordinates. You're going to have an x and a y set of coordinates for each of those points. You're going to look at those x values, and then you're going to see which one of those x's is over here. Only one of them will be over here. So that's how you do it graphically. If you're going to do it mathematically, you don't have to, probably won't have to use your calculator at all. So it says if y is equal to 76 and y is equal to x squared minus 5, you want the places where they're both true, where you could pick an x and a y, plug them in here, and they're both going to be true. So if y is 76 in this one, it needs to be 76 in that one too. So that's how you're going to solve it. You're going to get rid of that y, and you're going to replace it with 76, because you want to know when y is 76, when is this true? What x makes this true? So now we're going to solve for x. First, I want to get rid of that -5. I want to do the opposite. I want to add 5. I need to do that to both sides. 76 plus 5 is 81. 81 equals x squared. To undo a square, you need to take the square root. So I'm going to take the square root of both sides. And what times itself equals 81? What's the square root of 81? That would be 9. But just remember, when you're taking a square root, you want it to be positive or -9, because both of those squared would be 81. So there's our x for those 2 points, positive or -9. Since y is always 76, one of those points is going to be 976, that point of intersection, and the other one will be -976. And they want to know just what's a possible x. That's why they use the word possible, because there's 2 x's it could be. And we have our 2 x's here of 9 and -9. So let's look at our answers. And sure enough, there B, -9. That is our answer. Right. Number 12. Y is greater than 14. 4x plus y is less than 18. The point x 53 is a solution to the system of inequalities in the xy plane. Which of the following could be the value of x? All right. Again, 2 ways to do this, just like with the previous problem. You can do this graphically in your graphing calculator. You can do it mathematically. If you choose to put this in your graphing calculator, you're going to get something that looks like this. Y is greater than 14. If you were to graph y equals 14, it would be a horizontal line, but because it's greater than and not greater than and equal to, or equal to, it's going to be a dashed horizontal line. And this is not drawn to scale. Please ignore the grid marks in the background. This is going to be right here. This is 14. So this is y equals, oh, sorry, excuse me, not y equals, y is greater than 14. Also, when you have a greater than, when you're graphing, there's going to be some shading, because there's a lot of places where y is greater than 14, not just right next to this line. So when you put this in your graphing calculator, it's going to have all this shaded. And let's change this and make this blue. So we have blue line, blue shading. Let's see what's what here. All of this will be shaded because every point in this shaded area makes this statement true where y is greater than 14 for that point. All right, the other one, 4x plus y is less than 18. That's going to be a negative sloped line, a line with a y-intercept of 18 and a slope of -4. So it's going to be very steep. And again, it's a less than, so it's going to be a dashed line. And again, this is just like a little rough sort of approximation to show you what's going on. And this one is going to be shaded on the left side of it when you put it in your graphing calculator. So everything over here, every point in this shaded area is what makes it true. Now, the solution of the system of equations is the part where they overlap up here. It has to be true for both. So it's the shaded area. It's the area where both of the shaded areas overlap. That's the solution to the system of equations. So the question is, the point x53 is a solution to the system of equations. Which of the following could be the value of x? So you're going to zoom out and you're going to find where y is 53, because that's what you're looking for. X is, we don't know, and the y is 53. So you're going to go up here until you find where y is 53. And you're going to, because it's going to keep going up this way. And you're going to look and see which of these x values is in that shaded area when y is 53. Is it 9? Is it 5? Is it -5? Is it -9? Those are our 4 options. So you're going to look at that 53. You're going to kind of look at it over with your eyes. And go, okay, once it gets in the shaded area, which of these 4 points could it be? That's the graphing way. Like if I'm at x is -5, am I in the shaded area? The doubly shaded area, that's important. Because all of these are going to be in this blue shaded area because it goes this whole way across all the way up. So all 4 of these options will be in that blue shaded area. It has to be in the area where they're both shaded. So anytime, they ask, could this be a solution? Double shaded area. So that's the graphical method to do it. The mathematical method, I think, is actually a little quicker, but it doesn't matter which one you use. They're both going to give you the same answer. So we know x, and we don't know x, and we know that y is 53. Which of the following could be the value of x? All right, so x, 53. Well, the first equation, y is greater than 14. If I plug 53 in there, that's true. I don't have to do anything else. But what about the second one? The second equation, 4x plus y is less than 18. If y is 53, what must x be? Let's just do the math. Let's plug 53 in for y, and let's solve for x. So I'm adding 53. I want to undo that. I want to subtract 53 from both sides. And I'm going to get 4x on the left. And let's see, 18 minus 53 is -35. So I have now 4x is less than -35. To get rid of that 4, this is being multiplied, x times 4. We want to do the opposite. We want to divide by 4. And so I just have an x on the left, and then I am dividing by a positive number, so I do not have to flip this sign. Be careful of that. If this were dividing by a negative, you would have to flip that sign. Dividing by a positive, you don't. So -35 divided by 4 is -8 3/4. So what I have learned is that when y is 53, x must be less than -8 3/4. Which of these makes that true? The only one that is less than -8 3/4 is A, -9. And that's my answer. Number 13. Out of 300 seeds that were planted, 80% sprouted. How many of these seeds sprouted? When we're finding a percentage of a whole, we multiply the whole by the percent. So here we have 300 seeds and 80% sprouted. We multiply those together. 80% is the same as 0.8. And when we multiply this together, we get 240. So 240 seeds sprouted. This is one of those problems where there's multiple ways you can do it. It's just whatever makes the most sense for you. Some people look at it as saying, oh, 80%. 80% is the same as 4/5. What's 4/5 of 300? And they can look at it that way. Any way that you look at it is fine. You're going to get the same answer regardless of 240. Number 14. The function f is defined by f of x equals 4x. For what value of x does f of x equal 8? So when we say f of x equals 4x, it means when I pick a number, any number, and plug it into this function, what I'm going to get is 4 times that number. So if I were to plug 3 in, I'm going to get 4 times 3, or 12. Okay, so they're asking us is for if f of x equals 8, what number did I plug in to get that? So remember, the output here is going to be 4x. So I'm going to put that in right here. So the output was 4 times the original number. That output was 8. What was my original number? 4 times x equals 8. To undo that times 4, I need to divide by 4. 4x divided by 4 is just x. And on the right, 8 divided by 4 is 2. So when x is 2, f of x equals 8. Number 15, which expression is equivalent to 8x times x minus 7 minus 3 times x minus 7 all over 2x minus 14, where x is greater than 7? This is a lot more straightforward than it looks. It really is. They don't have as many of these anymore. I haven't seen them as many of these recently. These they look super complicated, but they're actually a lot easier than they appear. Man, this used to be their bread and butter, but it's been less of those. There have been less of those lately on the test, I've noticed. Okay, so on top, the first thing I want you to see is that we have matching binomials there, x minus 7, x minus 7. Now, if you have done in algebra, if you've done factoring by grouping, this probably looks familiar. This is like the middle step when you're factoring by grouping. And what you can do when you have something like that, and I'm going to do a sample problem down here, and then we're going to apply it to this. If I had 2 times x minus 5 plus x times x minus 5, and actually I'm going to reverse those. Put the x up here. Put the x here, x times x minus 5 plus 2 times x minus 5. I can rewrite this as x plus 2, I pull both of these, times x minus 5. The reason you can do this is why. If I said this, 5x plus 2x, what would you say that is? 5x plus 2x is 7x. I had 5 x's. I added 2 more x's. I get 7 x's. And how did I get this 7? I added 5 and 2 together, and the x stayed the same. That's what's happening over here on the right. I have x minus 5s, and I have 2 x minus 5s. So I can add these together just like I added 5 and 2 together. And that's how many x minus 5s I have. I have x plus 2 x minus 5s. So these are the same principle. Same thing going on. It does look different, but it's the same thing. So that's what's going on up here at top. We can rewrite this. So 8x, x minus 7s, minus 3x minus 7s would mean we have 8x minus 3 x minus 7s. Now 2x minus 14 on the bottom. There is a greatest common factor there. 2 and 14 are both even, so I can pull out that 2. So that's what I'm going to do. I'll take a 2 out. 2x divided by 2 is just x. That's what's left behind. And negative 14 divided by 2 is negative 7. That's what's left behind. Well, these are being multiplied by each other. 8x minus 3 is being multiplied by x minus 7, and 2 is being multiplied by x minus 7. When everything is being multiplied, we can cancel things out on top and bottom if they match. This does not apply if it's added. Like if I had x plus 3 over x, I go, oh, I got an x on top and bottom. I can cancel them out. No, they have to be multiplied. But in this case, we have some matching things on top and bottom that are being multiplied. There's an x minus 7 on top and an x minus 7 on the bottom, and they're being multiplied. So that little grouping is being multiplied, and that little grouping is being multiplied. So I can get rid of those groupings. And that leaves me just an 8x minus 3 on the top and a 2 on the bottom. And if we look over here, that is B. B is my answer, 8x minus 3 over 2. Number 16, line P is defined by 2y plus 18x equals 9. Let me write that over here. line R is perpendicular to line P in the xy plane, what is the slope of line R? They're wanting you to know, they're testing you on how perpendicular lines, how their slopes relate to each other. Parallel lines, perpendicular lines, those are the two you need to memorize. If you have parallel lines, their slopes are identical. So if this one has a slope of 3, that one has a slope of 3. Always. Doesn't matter where they are, what angle they're going, their slopes are identical. Perpendicular lines that form right angles, their slopes are negative reciprocals. So if this one had a slope of 2/3, this one would have a slope of negative reciprocal -3/2. And when I say negative reciprocal, another way it's often termed is opposite reciprocal, which actually is what I prefer, but I see negative a lot. So the opposite reciprocal. So if I was going from this direction, like I had this one and said this is a -3/2 slope, what is the slope of this perpendicular line? I would say, what is the opposite reciprocal, or the negative of it? What's the opposite of it? The opposite of a negative is a positive, and the reciprocal would be 2/3. We're just flipping those. Just as a reminder, if you have something that is a whole number, like say I had 5, the reciprocal of that is 1/5, because 5 is the same as 5/1. That's how you do a reciprocal of a whole number. And again, the opposite reciprocal. So first we need to find the slope of this line, and then we can find the opposite reciprocal. I'm going to use y equals mx plus b format, so y needs to be by itself, because once I do that, the m that's beside my x will be my slope. I'm going to move the x over first by subtracting 18x from both sides. Then I have 2y on the left and negative 18x plus 9 on the right. 2 times y, I want to undo that multiplying by 2 by dividing everything by 2. Then on the left, I have y equals, and on the right, I have negative 9x plus 9/2. But this is what I'm really looking at, -9. So I want the opposite reciprocal. It's negative, so my answer needs to be positive. And it is 9, so the reciprocal of 9, or the reciprocal of 9/1, would be 1/9, or 1/9. So this line, wherever it is, it must have a slope of a positive 1/9, and that is C. There's my answer. Number 17. F of t equals 8,000 times 0.65 to the power of t. Ooh, okay. F of t, and I wrote x. F of t equals 8,000 times 0.65 to the power of t. All right. The given function f models the number of coupons a company sent to their customers at the end of each year, where t represents the number of years since the end of 1988. Okay, so make a little note here. This is years. Okay. And 0 is less than or equal to t is less than or equal to 5. So they started at the end of 1998. At the end of 1998, that was year 0. And then they did it for 5 years, because t can be from 0 to 5. That's what that means. T is greater than or equal to 0, or 0 is less than or equal to t, and t is less than or equal to 5. Okay. If y equals f of t is graphed in the ty plane, which of the following is the best interpretation of the y-intercept of the graph in this context? Okay, so the y-intercept is where x is equal to 0, or in this case, t is equal to 0. Because they say the ty plane, this is t, this is y. Everything else is just like an xy graph. It's just the same. So 8,000 times 0.65 to the power of t. So the y-intercept, where it crosses the y-axis, is where t is 0. So the numbers, we have, okay, 8,000, 0.65. What does t being 0 mean? We said t was the number of years that they did this. At the end of 1998 is when they started. So no years had passed. T starts at 0. That's what this 0 is less than or equal to T. Okay, the number of years since the end of 1998. So when T is 0, no years have passed. It is just the end of 1998. No years have passed. Okay, so what happens in this equation when T is 0? 8,000 times 0.65 to the power of T, T being 0. 0.65 to the power of 0 is just 1. Number to the power of 0 is 1. So what's 8,000 times 1? It is 8,000. So at the end of 1998 was 8,000, and they said this models the number of coupons they sent. So we can say at the end of 1998, they sent 8,000 coupons. Okay, now let's look at our answers and see which of those most closely matches what we've just said. Okay, A, the minimum estimated number of coupons, because we're asking what does the y-intercept mean? We said it means at the end of 1998, they sent 8,000 coupons. Okay. A, the minimum estimated number of coupons the company sent to their customers during the 5 years was 1,428. What? No, where's 1,428? No. And their total number of coupons sent? No, it has nothing to do. Right, B, the minimum estimated number of coupons the company sent to their customers during the 5 years was 8,000. No, this was just at the end of 1998. That's out. C, the estimated number of coupons the company sent to their customers at the end of 1998 was 1,428. Nope. Let's hope D's right. The estimated number of coupons the company sent to their customers at the end of 1998 was 8,000. Ding, ding, ding. And there is our answer. Okay. Number 18. Triangle XYZ is similar to triangle RST such that, and even before I go any farther, I'm going to draw some triangles. So I don't know what they look like, but I'm just going to draw two triangles that are vaguely similar. So my first one is X, Y, Z. And the next one is R, S, T. Okay, such that X, Y, and Z correspond to R, S, and T respectively. I always find it weird that they do that because when you say X, Y, Z is similar to R, S, T, that's what you're saying. But hey, they're clarifying. They're making sure that we know that X corresponds to R, Y corresponds to S, and Z corresponds to T. All right, we're good. The measure of angle Z is 20. Okay, so when this angle is 20, then we know its corresponding angle, T, is 20. So I'm going to go ahead and write that on both. And we know that 2 times XY equals RS. All right, so it looks like RS is the bigger. I didn't draw those right. It says 2 times this equals this, so RS must be way bigger. Okay, what is the measure of angle T? And you go, wait a minute. Did I need to know that 2 times XY is equal to RS? No, you didn't. You just didn't. They love doing this with similar triangles. They throw in information, sometimes a lot of information that doesn't matter at all. I guess they're trying to get you to trip you up and make you think, well, if RST is a bigger triangle, it's twice as big, then angle T must be twice as big. And if you look at our answers, yeah, that is one of the options where the angle is twice as big. But no, that is extraneous. It doesn't matter. Angles of similar triangles are exactly the same. That's how you know they're similar, is that you have at least 2 angles that are identical, then those triangles are similar. So if angle Z is 20, its corresponding angle T is also 20. So the question, what is the measure of T? That is 20, C. And yeah, as you can see, they tried to put in there, they did a T, they did 20 times 2, they did a 20 divided by 2. They're really trying to be tricky, and they just did a 2. But no, corresponding are the same. Z and T are the same. They're both 20. Your answer is C. Number 19, y equals 6x plus 18. One of the equations in a system of 2 linear equations is given. The system has no solution. Which equation could be the second equation in the system? Right, so y equals 6x plus 18. This is a line. It has a y-intercept up here around 18. That's what that 18 there means. And that 6 means it has a very steep positive. Oh, that was really bad. Very steep. I can't draw this freehand, not on a computer screen with a stylus. I just can't. I know my strengths do not lie there. But it's a very steep little line that's supposed to be straight that goes through 18. So it looks something like that. Now, if it says there's a system of equations, so there's another line here, a linear equation, the system has no solutions. Think about if I had this ruler, any angle that I put this at, eventually it's going to cross this line, right? Like even if it's like that, it's going to cross down here somewhere. Except there's only two situations where it won't have a single solution. One is if it's parallel and it's separate, in which case it has no solutions, or when it's parallel, it has the same slope, and it's like on top of each other. They are the same line. In that case, it has infinite solutions. So those are your only two really options, is it's no solutions or infinite solutions if lines have the same slope. Any other situation, they're going to intersect once. They are. Only if they have the same slope will you have those two options. In this case, it is no solutions. So I know it is a line that is parallel and it is somewhere. It could be there, it could be there, it could be many places, but it's parallel. It's not touching it. It's not on top of it. It has no solution. So again, as I said before, same slope. That's the key. So we're going to look at these and see which of them has the same slope as the top one. And I mentioned in passing, if you caught this or not, that little 6 there by the x, that is our slope, because this is in y equals mx plus b format, where the b, that number by itself, is the y-intercept, and the number by the x is our slope, the m. So our slope is 6. So we want to look at all of these and see which of these has a slope of 6. So let's look at our first one, negative 6 plus y equals 18. To get the y by itself to be in this slope-intercept format, we want to get rid of that 6x. We want to move it to the right, so we're going to add 6x to both sides. So I'm going to have that y left by itself on the right, and then, on the left, and on the right, we have 6x plus 18. And this is where you need to be careful, because if you're doing this quickly, and you look and you go, hey, 6, slope of 6, done. A is my answer. Is it though? No, it's not, because look, 6x plus 18, it's the same line. This line is right on top of the other line. It would have infinite solutions. All the solutions there are going to be in there. This one, no solution. So A is not my answer. It's close, but it is not my answer. Marking that one out. All right, our second one, negative 6x plus y equals 22. Same sort of thing. I'm going to get rid of the x on the left by adding 6x to both sides, and I get y equals 6x plus 22. And there we go. That's what we're looking for. It's in that y equals mx plus b format, so I know my 6 is my slope, my m. That's what I want. I want the same slope, and it has a different y-intercept, so it is not right on top of it. It is parallel to it. There's no solution. B is my answer. If you went through and did C and D, for those you're going to get a slope of 12 for both of those when you go through this process. And again, that's not what we're looking for. It has to be the same slope. That's the only option. Has to be the same slope. B is my answer. Number 20, what is the area in square centimeters of a rectangle? And I'm going to go ahead and draw this rectangle with a length of 34 centimeters and a width of 29. You know, I never can remember which side is the width and which side is the length, but you know, it doesn't really matter, honestly. It just doesn't for this, because they're asking what is the area, and the area of a rectangle is length times width. So I just need to multiply these together. There isn't any any extra sort of math or variables or anything unusual going on. We just need to multiply. So 29 times 34 is 986. So my answer would be 986 centimeters squared. But because on this test we're having to fill it in, we're not going to write centimeters squared. When we're filling it in, we're just going to write 986. But any other situation, don't forget centimeters squared. (21) y equals 4x plus 1 and 4y equals 15x minus 8. The solution to the given system of equations is x and y. What is the value of x minus y? Right. So anytime you have a system of equations, there are several ways you can solve them. You can solve by graphing. You can solve by substitution. You can solve by elimination. Me, I prefer to do like a substitution elimination. There are definitely instances where graphing is the way to go. This one, it's any way you want to do it. If you're wanting to do it by graphing, you're going to put both of these into your graphing calculator and you're going to find the precise point where they cross, where they intersect. Be very careful, make sure you have the exact right point. Sometimes it can be difficult depending on the graphing calculator and the setup you're using. Just be careful there. And once you get that value of x and y, you're going to do this x minus y and get your answer. So there's not real much to explain there other than look at the graph, look at the two lines, figure out where they cross. If you're wanting to do this mathematically, you can do it by either substitution or elimination. Either way, it works. Substitution is kind of set up here for you, where it says y is equal to 4x plus 1. So since there's already a variable isolated, you know that y is equal to this. You can plug this in wherever there's a y in the other equation. That will let you solve for x, and then you can solve for y. My preferred method tends to be elimination, because like if I do this, if I do the 4x plus 1 in there, you get the binomial, either way works. I'm actually, you know what? I'm going to show you both, and then you can decide what you want to do. I'm giving you choices, right? Right. All right, so let's say if I do substitution, I'm going to plug that 4x plus 1 in for y. And I have 15x minus 8 on the right. So on this left side, I'm going to distribute. 4 times 4x is 16x. 4 times 1 is 4. And still on the right, 15x minus 8. And then I'm going to move this x over here by subtracting 15x from both sides. So I just have x plus 4 equals, and there's negative 8 on the right. Then to get rid of that plus 4, I'm going to subtract 4 from both sides, leaving me with x on the left, and negative 8 plus a negative 4 is negative 12. So x is negative 12. And then to solve for my y, that y equals 4x plus 1, I'm going to replace that x with my new negative 12, and I really cramped that in there, so I'm going to make it a little more. 4 times negative 12, okay, plus 1. 4 times negative 12 is negative 48, plus 1 is a negative 47. So I know my x is negative 12 and my y is negative 47. Let me say, what is x minus y? Be careful here because we got these negatives going about. That would be negative 12 minus a negative 47, which would be a positive 35. Boom. Okay, so that is the substitution method. All right, elimination method, which if we have done this right, will give us the exact same thing. Elimination is where you want to make something cancel out. In this case, I would think the easiest, we're going to add these equations together. I think the easiest is to make the y's cancel out, because this is a positive 4y. I want this to be a negative 4y. So I'm going to multiply all of these by negative 4, and then those y's will cancel out. So when I multiply y by negative 4, I get negative 4y. When I multiply 4x times negative 4, I get, come on, there we go, negative 16x. And when I multiply 1 times negative 4, I get negative 4. I'm just compressing. You can write all these out separately, obviously. All right, when we add all these together, I get negative 4y plus 4y equals 0. Then I get negative 16x plus 15x is negative x. Negative 4 plus negative 8 is negative 12. Then I'm going to add x to both sides, so I can get x on the left and the number on the right. And that gives me, on my left side, just x, and on the right is negative 12. So here we are back again, like we set up there. X is negative 12. Then the same process, I would take negative 12 and plug it into that original y equals 4x plus 1, which would give me negative 47. And we're back to x minus y. Negative 12 minus a negative 47, which is a positive 35. Again, whether you do graphing, substitution, elimination, they all work. They're all going to give you the right answer. Just be really careful in that x minus y, since you have negative numbers in both of those. Number 22. 5x squared plus 10x plus 16 equals 0. How many distinct real solutions does the given equation have? There are two ways that you can do this. You can graph it, or you can use the discriminant. If you graph it, what you're looking for, the solutions are going to be where it crosses the x-axis. So if it's a parabola, which it is because we have that x squared out front, parabola is going to either look like, this is a positive parabola, that's why I'm drawing it like this. It's either going to be up here somewhere, or it's going to be, it's going to be above the x-axis somewhere, or it can be on the x-axis somewhere, or it can be below the x-axis somewhere. If it is above, there will be no solutions because it is not crossing the x-axis. If it is right on it, there will be one solution because it's just touching at one point. And if it's below, there will be two solutions. So you have those two spots where it's crossing. So that's how you do if you look at it graphing. Using the discriminant, it's based on the quadratic formula when you're factoring, solving for x, that kind of thing. And it's this whole negative b plus or minus square root of b squared minus 4 times a times c all over 2a. And that will give you the answer, the solution. So when you're doing this, you have a square root right here. If there is a negative number under this square root, then there are no real solutions because we can't have a real square root of a negative. If this under here is 0, then we have one solution because this plus or minus is how you get the two solutions. Like say, if I do this math and I get 2, then this would be negative b plus 2 divided by 2a and negative b minus 2 divided by 2a. Two different answers. But if I did all this and I get 0, negative b plus 0, negative b minus 0, same difference, one solution. So this little bit under the square root is the discriminant. That's the name of it. B squared minus 4ac. So if you apply this b squared minus 4ac to any quadratic, you can tell without having to graph it or without having to solve for x how many solutions it has. And when we say b squared minus 4ac, this is referring to like this. The a is the number that's by the x squared, b is the number by the x, c is the number that's by itself. Okay, so b squared minus 4 times a times c. My b here is 10. So we're going to have 10 squared minus 4 times a times c. My a is 5. And my c is 16. I can already tell where this is headed. So we have this 10 squared out here. 10 squared is 100. And inside here, 4 times 5 is 20. 20 times 16, that's a lot more than 100, isn't it? Yes, it's 320. So 100 minus 320 is negative 220. It is a negative number. If I have a negative number under that square root, there are going to be no real solutions. So D is my answer, 0. Number 23, a certain park has an area of 11,863,808 square yards. Wow. What is the area in square miles of this park? 1 mile equals 1,760 yards. If you're having trouble visualizing square yards, square miles, think of it as square feet and square yards, kind of like a smaller scale, and then we're going to scale it up to kind of get the idea of what's going on. So if I have a square yard, it is a yard on each side, 3 feet by 3 feet. How many square yards, how many square feet are in that square yard? 3 times 3, there's 9. There we go. 9 square feet are in that square yard. So we multiplied the feet by each side to find out how many square feet are in the square yard. So we're going to do that same thing with square miles and square yards. Same principle. So a square mile is going to be a mile on either side, or as they're reminding us, 1,760 yards by 1,760 yards. So if I wanted to know how many little yard by yard, square yard things there are in here, I'm going to multiply 1,760 by 1,760. And I don't know about you, but I don't know what that is off the top of my head. So I'm going to use my calculator, and I find that it is 3,097,600. So that is how many square yards are in 1 square mile. So if this is how many square yards I have total, I say how many square miles is that? I need to take that number. Now 11,863,808. So that's how many total square yards. There are 3,097,600 square yards in a square mile, and I divide those to find out how many square miles there are, and I get B, 3.83. Honestly, this is one where you can I think you can kind of estimate it, and you can get the right answer as well, because these answers are so wildly different. They're so different from each other. So frankly, I think like if you were, like say you didn't have a calculator and this kind of thing, or you're just wanting to double check your answer, I would think you'd say, okay, 1,760, that's like 1,800 approximately, and we're estimating here. It's like, okay, without a calculator, I can multiply 18 times 18 much easier than I can 1,760 times 1,760. So 18 times 18 is 324. And anytime you're multiplying things that have zeros on the end, you can just multiply the parts before the zeros and then count how many zeros there are and add them after. There's a little fun math fact for you. I've got 4 zeros total. So 1, 2, 3, 4. So about 3 million. And this is about 12 million. 4 times. Ta-da. Confirmation. That's an estimated way of confirming, yep, we did it right. We correctly typed it into our calculators, which I don't think that's a bad thing to be able to estimate it like that and then confirm your answer, since when you're typing in those large numbers, it's very easy to make a mistake. But that is our answer, B, 3.83 square miles. 24. Which of the following equations represents a circle in the xy plane that intersects the y-axis at exactly 1 point? They're just testing your knowledge of the equation of a circle. When you have a circle, and I'm not going to use these numbers at first, I'm just going to use random numbers. Here is your baseline for a circle. X squared plus y squared equals r squared. That is a circle with its vertex at the origin, and that r squared is the radius squared. So if it was, say, 25, that means its radius is the square root of that. The radius is 5. So 5, 5, 5, 5. Drawn poorly, but you get the idea. That would be x squared plus y squared equals 25. If you want this circle to move anywhere, you have to start adding and subtracting from the x squared and the y squared. And it's always going to move it in the opposite direction. So if it was x minus 1 squared plus y plus 2 squared. That is going to move it, because it's minus 1, it's going to move it positive to the right, 1. And then that plus 2 is going to move it down 2. It's moving the center of the circle. I think I said vertex earlier. That was a mistake. Sorry, the center of the circle. Sorry about that. And then we would still have that radius squared, whatever it is. So in this example, let's say if I had x minus 1 squared plus y plus 2 squared equals, let's say, 36. That would mean I had a circle that it moved, the center moved to the right 1, and it moved down 2, again, opposite of both of those. And so there is its center, and then it would have a radius of, why it did that. There we go, back to drawing. Thank you, whiteboard. You never fail to disappoint me. Right, and then I have a circle of 6, because 36 is the radius squared. You take the square root, radius of 6. That's a really quick recap of, what the equation of a circle is. So let's look at these equations of circles that we have. First one, we want one that intersects the y-axis at exactly 1 point. So that means it's a circle and it is just touching at one little point, and that's it. All right, so first one, x minus 8 squared plus y minus 8 squared equals 16. So minus 8, that means it's going over here 8. And then y minus 8 means it's going up 8. And equals 16 means a radius of 4. So that radius is only like this. That's not touching anything. Nope, that's not it. A is out. Right. B, cross out A. Okay, x minus 8 squared. Okay, so we're still going to the right over to 8. Y minus 4 squared. This time we're only going up to 4. Still 16. Square root of that is 4, so our radius is 4. But if our center is right there, radius of 4, it's going to touch the x-axis, but not quite getting over to touch the y. Okay, so B is out. Let's look at C. X minus 4 squared plus y minus 9 squared equals 16. Okay, so x minus 4, so we're over here at a positive 4. And y minus 9, so we're up here at positive 9. Okay, and radius of 4, because again, 16 is r squared. Square root of that is 4. Okay, so it's going 4 down, 4 to the right, 4 to the left. Hey, there we go. It is touching the y-axis at exactly 1 point. C is our answer, but just to double check, let's look at D. D says x squared, so that means we're at 0, but then y minus 9, so that means we're up here, so our center's up here, and a radius of 4. This is not going to work either, because if I continue this, as you see, it's going all the way around. It's going to intersect the y-axis at 2 points. So confirmed, C is my answer. 25. In triangles A, B, C, and D, E, F, angle B and E each have a measure of 27 degrees, and C and F each have a measure of 41 degrees. Okay, I'm just going to draw. So we got A, B, C. Let's see, A, B. Whoa. I probably drew this poorly, but we're going with it. So A, B, C, and I have D, E, F. Okay. All right. So in triangles A, B, C, and D, E, F, angles B and E each have a measure of 27 degrees. Okay, so B and E both measure 27 degrees, so they are congruent to each other, okay? And angles C and F each measure 41. Another pair of congruent angles. Which additional piece of information is sufficient to determine whether triangle ABC is congruent to triangle DEF? Okay. Now we already have enough to know they are similar. Similar, you just need 2 angles. The rule is angle, angle, similarity, and we have that. For congruent, you need something extra. You need a side. You need at least one side, and you have to make sure you're using the right side. So the different ways you can prove something is congruent are side, 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 angle, angle, side, angle, or angle, angle, side. And these ones that are in order, like angle, side, angle, is you're marching around the triangle left or right, and they have to be coming in order. So for side, angle, side would be like this side, this angle, this side. You're moving around either direction. Or this side, this angle, this side. Okay, so we have two angles. So which of these could we use? We just need one additional piece of information. Now, side, 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 that one's going to be out. We don't have any sides. Side, angle, side, that one's going to be out because, again, we have two angles. We don't, giving us another side or something is not going to help. We already have two angles. It's going to be one of these. So we need an additional side. We either need angle, side, angle, in which case it would be this one because it would be angle, side, angle. So we would need to know that BC and EF are congruent. So that's a possibility. So this one we would need that BC is congruent to EF, and that would give us angle, side, angle. Then we have angle, angle, side, and that can go either way around. So it could be angle, angle, side, or it could be angle, angle, side. So either way, so I can know that AB is congruent to DE, and that would give me angle, angle, side, or that AC is congruent to DF, and that would give me angle, angle, side. So any of these we could do. Let's look at our options now and see which of these they're providing us. So for A, it says the measure of angle A. No, that wouldn't help us. Having all three angles would just prove more proof, I guess you'd say, which you don't really need, that they are similar because of angle, angle, angle similarity. But we don't care about similarity. We care about congruency. A is out. B, the length of side AB. Well, that's part of this one down here, but it's not all of it. Just knowing AB wouldn't help. We would also need to know DE. So B is out. C, the lengths of side BC and EF. Yes, there we go. If we knew the lengths of side BC and EF, we'd be able to tell if these triangles were congruent or not. Because if they are the same, they are congruent. If they are not the same, they are not. So we would need to know the lengths of sides BC and EF. That is our answer, C. And just to confirm, let's look at D. No additional information is necessary. No, that's not right. We know they're similar. We don't yet know they're congruent. We need those lengths. C is our answer. Number 26. Two data sets of 23 integers each are summarized in the histograms shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10 but less than 20. The second interval represents the frequency of integers greater than or equal to 20 but less than 30, and so on. What is the smallest possible difference between the mean of data set A and the mean of data set B? There's a lot going on here. All right, so let's start by just making sure we understand what these histograms mean. Okay, so there's two data sets of 23 integers. All right, so we have data set A and B. And in each of these data sets, there are 23 numbers. They each have 23 numbers in them. And they're all integers, so there's no fractions, there's no decimals. They are just nice, round, lovely numbers. So they're summarizing. They're looking at these data sets and they're summarizing them. So the first interval, when they say the first interval, it means this first area here, represents the frequency of integers greater than or equal to 10 but less than 20. So right here, what they did is they looked at data set A and they said, okay, I'm looking at all these 23 numbers. How many numbers are between 10 and 19? And they didn't find any, so they didn't put anything there. But when they looked at B, they said, there are 3 numbers in data set B that are between 10 and 19. And then they went on. For the next one, how many numbers are there between 20 and 29? Okay, in data set A, there are 3 of those. In data set B, there are 4 of those. And they just kept going. All right, So now they're asking, what is the smallest possible difference between the mean of data set A and the mean of data set B? How do we find the mean of a set of numbers? Like say if I had 2, 3, and 6, how would I find the mean? I'm going to add those together, and then I'm going to divide by the number of terms. So I had 1, 2, 3 terms. So 2 plus 3 plus 6 is 11, and I would divide 11 by 3, which would give me 3 2/3, and that would be my mean. That's how we find a mean. So for these data sets, to find the mean, so for A, I'm going to take all these 23 numbers, add them all together, and then I would divide by 23. And same with B. I'm going to add those 23 numbers together and divide by 23. And they're wanting me to know what's the smallest possible difference. So I want these two sums on top to be as close as humanly possible. How could I do that? Well, over here, data set A, you see how it has higher numbers in it. It's got numbers up in the 50s. It doesn't have any in the 10s. What about data set B? It's got lower numbers. We've got numbers in the teens, but we don't have any numbers in the 60s, in the 50s, excuse me. So if we want to make them close, we want to make data set A as low as possible, the low end of all these ranges. We want data set B to be as high as possible, the highest possible, so they can be close. So let's write down what are the possibilities. Okay, for data set A, let's say, okay, there's no numbers from 10 to 19, but there are 3 numbers from 20 to 29, and we want this to be low. Remember, data set A, we want to be low. Okay, so there's 3 numbers, and I'm going to say all of them are 20, the lowest possible value. So 20 plus 20 plus 20, which I'm shorthanding to write 3 times 20. Then my next group, my next interval, the lowest possible value there is 30, and there are 4 of them. So 4 times 30. And then the next one, we got from 40 to 49, and there's 7 of them. The lowest possible value would be 40, so 7 times 40. Okay, and then our last interval here is from 50 to 59, and there are 9 of them. So 9 times 50. And I'm dividing all of this by 23. Okay, now for B, what is in B? B, this lowest group that I have here, I have 3 of them, but I want it to be as high as possible. To go from 10 to 19, so 3 times 19. Next one, it can go from 20 to 29, the next interval. I want it to be as high as possible, so it's going to be 29. And we got 4 of those. Next interval can be from 30 to 39. I want it to be as high as possible, and we've got 7 of those. I have people that like patterns in the audience. They're probably seeing a pattern emerging here. And then for our last interval, 40 to 49, the highest possible is 49, and we have 9 of those. Okay, and to average all those together, we would divide by 23. Now, there's 2 ways that you can do this. They are both right. One is a lot faster, but if you don't see this, it's okay. You can do it the longer way. Don't worry about it. Like if you get this problem on the test and you're like, oh, I didn't see the shortcut, it's fine. Totally fine. Just be careful. So the long way is to type all of this into your calculator. Be very careful with it. If you're wanting to do it all in one go, I would recommend doing parentheses outside of those 2. And doing like parentheses, then parentheses 3 times 20, parentheses plus parentheses. Type it all in, make sure you have those exterior parentheses, and then divide by 23, and then do the same for B. And then see what your 2 averages are, and how close are they? What's the difference between them? And that would be your answer. And that's totally fine. That will get you the right answer. Here's the sort of eureka moment, and the SAT honestly used to have a lot more of these, what I call eureka problems, where you have to have this sort of epiphany to go like, oh, I see what you're doing, like it's a puzzle. They're not as many, but they're still there, and this is one of them. Look at how close these are. We've got 3 times 20 and 3 times 19. 4 times 30 and 4 times 29. 7 times 40, 7 times 39. 9 times 50, 9 times 49. What is going to be the difference between these two sums? Here I have 20 threes. Here I have 19 threes. That is the difference of a single 3. Here I have 30 fours, and here I have 29 fours. What's the difference between them? This one is 1 4 less. Next one, 7 40s. Excuse me, 47s is the way to look at this, and 39 sevens. How many? What's the difference there? A 7. This one has fewer 7s. And finally, we have 50. Whoa, no, not highlight, not erase. 59s and 49 nines. This one has 1 fewer 9s. So this number on the bottom is 3 plus 4 plus 7 plus 9 smaller. And if you add that up, you get 23. And what is 23 divided by 23? 1. So this number on the bottom is 23 smaller than this on the top. And 23 divided by 23, because we're going to divide both numbers by 23, is 1. And that's B. Again, if you have that sort of little like, wait a minute moment, and you see this pattern emerging, that's great. And you can do this a little more quickly. But again, also you have a calculator, and if you're just doing this, totally fine as well. You still will get the answer. When you get these two averages, these two means, they will be 1 apart from each other. So our answer is B. Number 27. A right triangle has legs with lengths of 24 centimeters and 21 centimeters. So right off the bat, I want to draw it. It's not half bad. All right, so a right triangle and its legs are 24 and 21 centimeters. If the length of this triangle's hypotenuse in centimeters can be written in the form 3 square root of d, where d is an integer, what is the value of d? There are 2 ways right off that I can see doing this. I'll show you both ways. So both of them are going to use the Pythagorean theorem, which says for right triangles that the lengths of the 2 legs, on the legs A and B, if you square them and add them together, you get the hypotenuse squared. A squared plus B squared equals C squared. Now, one way you can do this is you can say, well, my A and B are 21 and 24. So 21 squared plus 24 squared equals C squared. And if I do this, if I do 21 squared, I'm going to get 441. If I have 24 squared, I get 576. And if I add those together, I get 1017. And that is my C squared. And to solve for C, I would need to take the square root of both of these. So C is equal to the square root of 1017. And I need to simplify that. Are there any perfect squares inside of C? Yes, there are. I'm going to start at the bottom. I'm going to start with 4, 9, 16. Just go up through the easy ones. You can also use a factor tree. But I find a lot of times I just start with those low ones. And when I divide, I know 4 won't go into it evenly because it's not an even number. But 9 will, because 7 plus 1 is 9. A little shortcut out there. If you add up the numbers of the digits, individual digits, and it adds up to something that's divisible by 9, then the number is divisible by 9. Math tricks. So I'm like, yes, 9 is going to go into this. So I can write this as the square root of 9 times, and it's 9 times 113. And then you can split those up. You can say square root of 9 times square root of 113. Square root of 9 is 3. And then you just have square root of 113 left. Hey, and they said hypotenuse is 3 times square root of d. What would d be? D is 113. So that's one way you can look at this. There is a different way you can look at it where you bring the 3 square root of d into the equation down here, and I'm going to show you that method next. So you can pick. Either of these are going to work. It's whatever makes the most sense to you. Use it on the day. So at this point right here, where you're doing the 21 squared plus 24 squared, instead of having c squared, solving for c, and then making it equivalent to that 3 square root of d, I'm going to take that 3 square root of d and put it in right here. So it's 3 square root of d, 3 times the square root of d is what we're saying there, squared. We're going to do the same thing we just did. Okay, 21 squared is, I had to write it down because I didn't remember it offhand, 441 plus 24 squared, which is 576. And so all that equals 1017. And on that right-hand side, we had 3 square root of d squared, which would mean 3 times the square root of d times 3 times the square root of d. 3 times 3 would be 9. And square root of d times square root of d would just be d. So 1017 equals 9 times the square root of d. Since we're multiplying by 9, if I want to get rid of that, I need to divide by 9. So 1017 divided by 9 is, you guessed it, 113. 113 is d. Personally, I think this method is a little easier since you don't have to look for the square root, simplifying the square root. And as with any mathematical problem, pretty much, there's multiple ways you can look at it. Again, they're all correct. In this case, both of these different, I should say both correct ways of looking at it. So just whichever way makes the most sense to you. But just anytime you get one of these problems, because this one's a little different, and then they've got the variable in the hypotenuse, and they're kind of halfway giving it to you. Anytime you see a right triangle and you've got lengths of legs involved, Pythagorean theorem is usually going to be your friend. A squared plus b squared equals c squared. And again, both ways that I would recommend tackling this problem, you use it in both. So there you go. 113 is your answer, and you've come to the end of this section. Congratulations. Hey guys, if you want to help me keep making these videos, please check out my Spreadshop and Etsy stores. Links are down below, where you can find fun things like this slightly sarcastic coffee mug or this slightly arrogant sweatshirt. And if this was helpful or useful in any way, please let YouTube know so I can keep helping you and others like you. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.